Hi everyone, in this tutorial we're going to take a look at how to create a piled wall system just solely using Revit 2023. This particular tutorial will work on pretty much any version of Revit. And we're going to begin by actually creating the families themselves. On the home screen, let's go ahead and select New Family. In the New Family Select Template File dialog, we'll begin by selecting a metric structural foundation template file. We'll then click Open. To begin, we'll create our parametric framework using reference planes. On the Create tab in the Datum panel, select Reference Plane. To create the reference planes, it's much quicker to offset these planes rather than draw them from scratch. So in the Draw panel, we'll select Pick Lines. And on the Options bar, we'll select our Offset. So initially I'm going to create a pile that is 1000 diameter, so I'll type in 500 for my offset. I'll then offset the reference plane to the right, and then another one to the left, another one above, and the last one below. We'll then add some aligned dimensions to our reference planes. On the Quick Access toolbar, let's select Aligned Dimension, and we'll place equal dimensions across the 3 vertical reference planes, and make them equal, and we'll do the same on the horizontal reference planes, and again we'll make those equal. We can then put an overall dimension in to control the diameter of our pile. To release the dimension command, we'll select the Modify button on the ribbon. We'll then select both of the 1000mm dimensions by holding down a Control key, and on the Modify Dimension tab, we'll go ahead and create a parameter. We'll simply name this Pile Diameter. This will be a type parameter, and you can see here it's going to be a length, and we'll group this under Dimensions. We'll now go ahead and create the geometry for our pile. To do this, we'll select the Create tab, and on the Forms panel, we'll select Extrusion. This is going to be a round pile, so of course, in the Draw panel, we'll select Circle. I'll begin by sketching the circle from the intersection of the 2 default reference planes, and then we can just snap to the intersection here or here to create the circular reference. We'll then label this with a diameter, so again on our ribbon we can select the Diameter Dimension tool and place a diameter on our newly sketched circle. We'll press Escape and then select that diameter dimension, and again we'll now link this to that same pile diameter. We can then go ahead and select the green tick to finish the extrusion. To set the length of the pile, we'll go ahead and open up a front elevation. We'll then zoom out and we can see we have our reference level here. So we'll create a new reference plane at the bottom. So we'll select the Create tab, and in the Datum panel, we'll select Reference Plane. I'll then sketch a reference plane in here. We'll make that dimension permanent. We'll select the dimension, and again, we'll create a new parameter. And here, I'll just simply name this Pile Length. In this case, I'm going to make this an instance parameter, so it's easy to control the length of each of the piles. We'll then click OK, and you can now see that parameter has been created. We'll then select our extrusion, and we'll use the shape handle to connect that to the bottom reference plane. We must make sure that we constrain that, and we'll do the same here, and connect that to the top reference plane, and again constrain. We can now test this by opening up the 3D view, and we can now see our pile. To test the dimensions, on the Modify tab in the Properties panel, we'll select Family Types. In the Family Types dialog, we can now see that we have our pile diameter and our pile length. Now I'd like these to be at the top of the dimension list, so I'm just going to move these up. And we'll do the same for our pile length, and we'll move that up. Okay, so we can now test our pile diameter. Perhaps I'll make this 500. Click Apply, and we can now see that's changed. And we'll set an initial pile length of perhaps 10 meters. And again, click Apply, and we can see that that's updated and changed. Okay, so finally we have to assign a material to our newly created extrusion. So we'll select the extrusion, and in the Properties palette under Materials, we'll associate this family parameter. Now, because we started with a structural foundation template, you can see that we already have a built-in parameter to control the structural material. We'll simply utilize that. And the idea here is we want to create a primary pile and a secondary pile. The primary pile will be, of course, the first one board, and this will be the soft concrete. And then the secondary pile will be the second one board, and that will be board once the primary piles are cured. And this one will be our reinforced, slightly harder concrete. So to do this, we'll go to our family types dialog, and we'll generate a new family type. So I'm going to name this one primary pile. We'll then select our structural material, and we'll just go and browse here to our materials browser. I'll just search for a grade of concrete, so this is one of the out-of-the-box ones. And we can see here we have concrete cast-in-place concrete. I'm actually going to use an English way of looking at this, which will be in situ, but you can obviously use any grade of concrete you like. So if I just type in the word in situ, you can see we have a material here. We'll bring that up. And also what I'm going to do here is change the graphics. So I want to have this using a solid fill pattern. So we'll click on solid fill, and we'll use a light grey to represent this particular pile. Whilst we're here, we may as well create our second material as well. So again, I'm going to click on the concrete area here inside the library. Let's say that I want to use something like C40 concrete, so we can go and search for that. And then we can add that in up here. Again, I'll change the cut pattern. So this time I'm going to use, again, solid fill, but I'll use a slightly darker shade of grey so I can differentiate between the primary and secondary piles. So of course, the one I want to actually assign here is going to be our in situ. So I'll clear our search in here. You can see that there's my in situ concrete. That's been assigned here to our primary pile. We'll then create another new type, and of course this will be our secondary pile. We'll then again leave the pile diameter and the pile length the same, but I'm going to now assign that different grade of concrete. So that will be our C40. So this is the harder concrete pile that's going to be reinforced. We'll then click OK. So there's our pile with the two family types now created. We'll go away and save this. So we'll click on Save. I'll just save this onto my desktop for the minute. And here I'll call this one Concrete Pile. Let's now test this out in a new project. So we'll create a blank project. So we'll go to the File tab. We'll select New and then Project. In this case here, I'm just going to use my out-of-the-box structural template and click OK. Okay, you can see that this template takes us into the level 2 plan. I'm just going to change that and go to the level 1 plan. I want to create some model lines just to represent the path that my piled wall is going to take. So in this case, we'll just have a vertical line up here somewhere. Perhaps I'll have a line going off at a bit of an angle over there, and then we'll finish up over there. To place the pile, on the Structure tab, we'll select Isolated Foundation. And of course then, we'll go to Load Family to now go and load our newly created pile. We'll then click Open to load up that family. Of course, if we look in the Properties palette in the Type selector, you can now see we have our concrete pile and our two different types. So we'll start with our primary pile. I'll leave the pile length set to 10,000, and you can of course see that that's an instance parameter. We'll zoom in here, and then we can place down that first pile and perhaps the second pile. What I want to do here is just dimension between the two piles. So of course the engineer might actually give us the distance between these piles. In this case, I want to set this to perhaps 800. Okay, so let's now go ahead and place in our secondary pile. So we'll go to our Isolated Foundation tool. Again here, we'll check our secondary pile, and now we can place that in. Now I want to make sure that this is absolutely precisely accurate. So we'll go to Dimension, and we want the center distance of this one to be 400. So we'll just set that. Okay, and there's our layout. Now, of course, what's going to happen is this pile wants to actually be cut in the two primary piles. So what we can do here is just switch the join order. So we'll go to the Modify tab, go to the pull down by join, and we'll go to Switch Join Order. And of course, it doesn't really matter which order I pick these in. They'll change that join order. And of course, that's the appearance that we're looking for. So once we've got something like this, we could obviously now create another pile in here just by simply copying this. So we'll copy this 800 millimeters up here. Like so again, I'll just get ahead and switch that join order. Like so we can then start to do some copying. So we can select these piles here, for example, and then just go from the center of here to the center of here. And again, we can just do a few of these, just to get us going. Of course, once we've got a few more of these done like so, then we can obviously copy this a bit more effectively just by taking those piles there and then copying those across. Okay, we'll just copy a few of these up. So obviously this is a manual process. You could automate this with Dynamo, but I wanted to just show you how you would actually do this slightly in a more manual way. And we'll copy this one, see how close we actually get to that intersection, and that's actually pretty good. So we'll take this one and we'll copy that one up there as well. So you might need to do some adjustment here because of course the overlap won't give you exactly what you want to get to that end pile over there. But now when you change the direction, so of course now I want to have this pile, what we want to do is create similar, and we want to then press the space bar to make sure that this is effectively rotated. And I'll show you why that is, because when we come to now dimension this one, we want to obviously make sure that we can get the right angle on that pile. Okay, and we said that that will be 400. Okay, and again there you can now see I've got that next pile ready to go. So if we now change the view range, so I'm just going to type in VR in here. What we'll do is we'll make that cut plane say -100, and then we'll click apply. We can obviously now see our cut working. We can obviously see all of the piles are looking quite nice. Obviously, if we put a capping beam on top, they would be cast into hidden detail. If we take a look at the 3D view now, again, we can see all of our piles nicely placed out. Of course, if we choose the realistic mode, then we'll actually be able to differentiate between those primary and secondary piles that we saw in our piled wall. Right, so, and in fact, what I'm doing here is obviously the grade of concrete is probably using the same material type, but we could obviously change that to make that a bit more visible. And there we are. So we can now see a process we can use to create piled wall systems. Hope that's been useful.